PZT is a program that allows you to show the effect of a system on a time waveform. Let me show you how this works by an example. Grab a sound file, and I'm going to ask you to turn down your speaker or your headphones because this will be pretty loud. So this panel shows the time waveform, and here it is.
She sells seashells.
It's a speech waveform which has been corrupted by a pure tone. And I work with students to design a filter in real time by moving poles and zeros around the Z-plane. That's going to remove the tone and leave the speech alone. So we start by saying, well, what is that tone? And we can either use a spectrogram or we can just zoom in on the leading part of the waveform. And you can see that the period of the tone is 1, 2, 3, 4. That means 2 pi over 4, pi over 2. So cosine of pi over 2. So we'll block that by putting a couple of zeros right there at pi over 2. Here you can see the frequency response of this notch filter, and we can play the response.
She sells seashells.
Well, pretty good, but not good enough. It's muffled because it's a pretty broad notch filter. So we'll fix that by taking a couple poles and moving them just on the inside of the zeros. That's pretty good, just about there. And let's play that.
She sells seashells.
The time waveform looks a lot better, and the frequency response looks a lot better too. Except the gain is a little bit high at omega is equal to pi and omega is equal to 0. That corresponds to z equals 1, so h of 1 is 2 over 1.81, so we can fix that by compensating with this by 1.81 over 2. That makes the gain at omega equals pi and 0, 1. And we can also look at that on a dB scale. Pretty nice notch filter. This program is one of a suite of programs that I have developed to explain DSP concepts to my students during lectures. There are now well over 24 programs covering many aspects of the material in the book, including complex exponentials and sinusoids, convolution, the DTFT, pole zero plots and their relation to frequency and impulse response, A to D and D to A conversion, including upsampling, downsampling, resampling, and aliasing, the design of many types of FIR filters and their application to the filtering of speech and other signals, the design of IIR filters, circular shift and convolution using the DFT, the discrete cosine transform, and the short-time Fourier transform. A selection of these programs is being made available to instructors who are currently adopting the book in their classrooms. For further information, please visit cambridge.org/Holton.